Good morning, everyone, and welcome to session 3.5, Analysis of Seismic, Hydroacoustic, and Infrasound Monitoring Data. We're excited to host more than 50 lightning talks showcasing cutting-edge research and innovative approaches across our monitoring disciplines. Thank you for joining us, and let's dive and enjoy this knowledge package session. Thanks.
Good morning to everyone. I am coming from military and university sector, and I am dealing with signal processing in hydroacoustics, acoustics, seismics, radar technology, and etc. In my presentation, I will show you our result which we obtained by using new method for statistical filtering of the bad data. We analyzed few examples in different areas, such as hydroacoustics, seismics, acoustics, and radar technology. In this first example, which is shown on the slide, I presented hydroacoustics data obtained from hydroacoustic station Jose Garcia during Krakatau eruption. As you can see, raw data are very noisy, and in the first moment look like that they are unusable. The explanation for this fact is in the following: that eruption was done above the water surface, and low seismic energy penetrated into the water, so hydrophone triplets placed in Jose Garcia measuring station hadn't good reception of these signals. But when we implemented our new method for signal analysis, and we succeed to remove all of these layer of noise, and you will see, if you go to see our presentation, what are the results which we are obtained. Please go to our presentation number 3. I'm speaker also for next presentation. Please, next presentation. Yes. In the context of this, our work, we developed one algorithm for time of arrival estimation on site. This algorithm can estimate time of arrival very precisely on site, and it is possible to use it as an alarm or to transfer only part of data around this event, it is unnecessary to transmit all the data which sensor captured. So if you're interested to see this, how this algorithm works and the results which we obtained, I think it is very significant, because time of arrival is very significant for knowing what happened, where happened, and when happened this event. Please come to the presentation number 4. Thank you.
Hello, I'm Siobhan Nicholson, and I am presenting on behalf of Phil Blum and other colleagues at Los Alamos National Laboratory who have been working on developments to the InfraPi software suite, which is a waveform analysis software. Some of you probably already have this software, so please come by to see some of the new developments that include a spectrogram density-based clustering algorithm that's being evaluated for single channels when we can't use array-based detection methods. And then also a Bayesian back projection localization algorithm that was developed and was included in a recent update. So come see us for some updates on this software. Thank you very much.
Good morning. My name is Fakadu Kabada, and the list of my co-authors are displayed on the screen. And our poster is devoted to the assessment of the impact of interactive analysis on detections during reproduction. So there are 6 actions to be taken. One is manually adding phases which were not picked by the automatic system. The second is association of phases which were already detected but not associated to any event. The third one is the association of phases which are invalid from the event. The fourth one is FK analysis, which is re-estimation of azimuth and slowness for proper location. The fifth one is renaming of phases. And the sixth one is retiming of phases. All this summary is already given here, but on individual basis, for individual stations, please come and visit our poster, which is P3.5-269 on board 16. Thank you.
Good morning. My name is Michael Roth. I'm presenting the Swedish National Seismic Network. The network is currently operating 80 broadband stations, and in our poster I will present you the infrastructure of the network and also all the routines and technical solutions which we are using to run the network. In addition to the 80 stations, our own stations, we are also retrieving data from 120 stations from the neighboring countries. And we are running a virtual network to monitor in real time Fennoscandia. We are also running, and those monitoring is done with the SeisComp and the Earthworm system. We are also running 2 more automatic processing systems focusing on very small events around magnitude 0 to 1 in Sweden. The events which we locate are automatically classified as earthquakes or as blasts, and we have about a 98% success rate. I can explain you on the poster. The real-time bulletin which we are producing, because we are taking an intersection of the bulletins, is more or less spurious-free. So we had, within the last 2 years, we had 10 spurious events. Otherwise, they were all real events. So if you are interested in our network and our processing, please visit our poster. Thank you.
Good morning, everyone. I'm from China, NEC. It's a pleasure to be here to introduce our work about machine learning. As we know, seismic data processing typically involves signal detection, phase identification, network association, and event location. The traditional methods often process single station waveform data independently, overlooking the inherent interdependencies between seismic stations. Here we present a unified intelligent framework plan based on the graph neural networks. The plan contains 4 modules. A facial extraction module with an encoder-decoder structure for waveform characterization and a phase picking module for P-wave and S-wave detection, and an association module for multi-event phase correlation, and an event location module for estimating epicenter parameters. The plan model takes both the seismic waveform data and the graph structured station information as the input, and directly generates catalogs. And tests with our real data sets demonstrate plan outperforms FaceNet and EQ transformer, highlighting its potential as a next generation model for automated seismic data processing. For more details, welcome to our poster. Thank you.
Good morning. My name is Patinya Ponsopin from Thailand Meteorological Department. My poster will show you about the earthquake location capability of Thailand seismic network. From 173 seismic stations in Thailand and surrounding area, we use a blunt approximation to estimate the threshold magnitude of the detection for each station, and we use a seismic noise signal level for each station and elastic property of the class to determine the completeness magnitude of the network. The completeness magnitude of the Thailand seismic network is around 2.9. Especially in northern part, we can detect the earthquake magnitude less than 1.5. For more information, please come to vote. No, not vote. Please come to see my poster. Thank you.
Hi, hello everyone. My name is Claire Labonne from French NDC, and with colleagues, we work in improving detection of small magnitude events using one component or three component arrays like Access in Norway. And with three component array, we can combine horizontal and vertical coherency, but they're still affected by coherent and incoherent noise. To deal with that, we clean up the data using principal component analysis in two steps. First, we remove current noise, and then we enhance weak signal. And this work led up to more than 55% more event detected when using denoise data on three components. And with a clear ACE wave, better phase coherence, and a more accurate detection. Thank you. Please visit me at e-poster and see you. Thank you.
Good morning, everyone. My name is Ch4, El-Khouli, researcher at Egyptian National Data Center in National Research Institute of Astronomy and Geophysics. My poster is about classification between natural earthquakes and underground nuclear explosion by using discrete wavelet, DWT, with integration of MRA multi-resolution analysis across different regions worldwide. For more information, please visit my poster with number P3.5 342. Thank you.
Hello everyone, my name is Cem Destici from Turkish NDC. As you know, on February 6, 2023, two major earthquake struck Turkey and causing the massive destructions. Unfortunately, this earthquake resulted the deaths of over 54,000 people and the collapse over 40,000 buildings. And we used the data was obtained from the IDC database. And infrasound and seismic arrival times were compared. And we used the GPMCC for the analysis. And we performed the infrasound analysis for each to measure earthquakes. According to studies, 5 IMS infrasound stations were able to record the first earthquake. Only 2 stations recorded the second earthquake infrasound signals. And finally, the findings indicate that infrasound network can be used to understand earthquake dynamics and to help improve the seismic monitoring networks. Thank you.
Hello, I'm Kyler Goddard from the United States NDC. My poster is a joint poster with the CNRST in Morocco. Using their in-country bulletin, we measured waveform amplitudes and created PS ratios. We then used those PS ratios as features in the XGBoost machine learning algorithm and did some clustering with UMAP and deployed that model against events from that station and another station in the network. Feel free to come by if you want to see how we use ratios as features in machine learning. Thank you.
Good morning, everyone. I am Korhan Şemin from Turkish NDC and also Kandilli Observatory and Earthquake Research Institute. My poster is about different deep learning pickers. You know, they are very popular in recent years, and rightly so. So in our study, we choose 3 different deep learning pickers and try to apply them to 2 moderate-sized earthquakes one in Istanbul in Marmara Sea and one in the Düzce city of Düzce. These are moderate-sized earthquakes, and we try to compare our Kandilli Observatory catalog with the deep learning pickers catalog. Our goal is not to find out how many more events the deep learning pickers find. We actually want to find out if the pickers completely find the analyst events and the timing of the peaks and how many of them are correct or not. So please come to my poster if you are interested. Thank you.
So hello everyone, I'm Widad Jin and I'm a mechatronics engineer and PhD student from Morocco. So as you know, every day seismic monitoring systems around the world collect massive amounts of data. The challenge is the manual methods are too slow and depend heavily on manual feature extraction. Traditional methods are too slow and depend heavily on manual extraction, which can delay critical decisions in global security and treaty compliance. So in our work, we introduce a scalable CNN-based framework that learns directly from data. We convert signal seismic into spectrogram, transform them into RGB images, and classify them using an enhanced mobile net architecture using a ghost module. So allowing us to reduce computational cost while maintaining a good performance. This means faster, more reliable, and more objective monitoring. Join our e-post to see how this combination of deep learning and lightweight architecture can revolutionize seismic data analysis. Thank you.
Good morning. My poster today is to evaluate the detection capabilities of deep learning models that are used in seismology. In our work, our objective is to refine the catalog, and to do that, we went through evaluation of several models to see how we can improve the detection capability of those models. We used 2 different data types from ocean bottom seismometers and also from land data. And with that, we use also two different detectors, peakers like earthquake transformer for land data and peak blow for ocean bottom seismometers. And in this process, we could detect two aspects that stand out. One of them is how we go about setting the classification threshold so that we don't miss or we don't overtake phases that are not supposed to be taken. Second point is how do we combine different models, different deep learning models to have a more effective and efficient processing pipeline. If you want to know more, please visit our posters outside. Thank you so much.
Okay, so good morning. So with our poster, we are presenting a deep learning algorithm, so a neural network, to predict in near real time infrasound transmission losses in the atmosphere. To model infrasound transmission losses can help to interpret better the IMS station measurements, but also to assess the IMS network detection capabilities, and finally to infer some atmospheric properties, such as winds or temperatures, at altitudes where direct measurements are scarce. And to do so, we introduced a recurrent convolutional neural network able to predict transmission losses with a great accuracy. So we obtain an average 8% error compared to a physical parabolic equation-based solver. And our approach is able to do these predictions in near real time, meaning that it can predict several hundred of transmission losses up to 4,000 kilometer long distance in less than 1 second. So this is a high computational gain time, and this will allow to model in near real time the global detection capabilities of the IMS network. So if you are interested to see the results, don't hesitate to come to my poster. Thank you.
Hello everyone, I am Alexander Shashkin from CTBT USA, and my poster is about NetVisa, a software package for associating seismic, hydroacoustic and infrasound arrivals. It combines probabilistic models with an inference algorithm. Generative models contain the information necessary to evaluate the probability of events, while inference algorithm searches for the most probable explanation of the data. Right now, we use what is called rolling priors. Every week, the models are relearned using 3 months of data. This allows them to adapt for changes like network reconfigurations or seasonal effects, though it also means the algorithms evolve week by week. In contrast, the long-term prior models use about 10 years of data for learning. This makes priors much more stable, but it's far too large to fit into memory. To handle this, we've made a lot of efforts to incorporate bucket-based learning into NetVisa. Come by my poster if you'd like to hear how we make it possible. Thank you.
Good morning, everybody. My name is Evangelos Telis. I'm a software engineer in CTBTO. Everybody knows ChatGPT, OpenAI, and the series of models, GPT series. Some of you may know that you can develop applications using these models. Unfortunately, for CTBTO, this is not always possible because of security and privacy concerns. So if you want to learn how we replicated OpenAI's infrastructure in our premises, come to booth 37 to learn more how we built a platform for developing application and end-to-end engineering platform. Thank you.
Good morning. There's an increasing need for detecting small events far away from our shores. And since we have all the seismometers on land, we need to adapt new technology. One way to do that would be to adapt DAS, and in our poster we will show several different events recorded by both seismometers and DAS. So please come by the poster, and please also come by the DAS event we are hosting tomorrow morning at 9 o'clock. Thank you.
Hi, so I'm Ryan Gallagher. I'm a seismologist developer at the International Seismological Centre. What this poster is going to be showing is the interactive CTBT link to the ISC database that is available to the IDC and all NDCs. This is a way of accessing ISC data specific for the CTBT and has some interesting features that are not available on the public ISC website. So yeah, if you come by the poster, I'll be happy to talk about it, and if you want a live demo, come down to the ISC booth downstairs and I'm happy to show you there. Thank you.
Good morning. My name is Abdurrahman Atmani from Ibn Zahra University. My poster is about a novel technique of seismic event classification, just using Euclidean distance function. No need of future extraction like in the EA techniques, nor heavy calculations or memory occupations like in classical other techniques. Despite its simplicity, it can achieve good results, but it needs a careful preparation of the data in terms of duration, normalization, and so on. A simple analysis and comparison of heat maps depicted below can evoke many questions. So if you are interested in this subject, please come to discuss and for more explanations in front of our poster. Thank you very much.
Good morning, my name is David Brown. My poster today extends some of the work I presented previously on infrasound source location, IMS arrays. We're using a neighbourhood algorithm to minimise the misfit function, which is expressed in terms of observed and predicted detection parameters for a given hypothesised source location. The neighbourhood algorithm does away with the necessity of calculating derivatives of travel times and also inverting overdetermined matrices. However, we're not calculating an ellipse error at the present time. So I've applied it to 3 topical infrasound events that have occurred in the network recently, including this event here, which was a mining truck that exploded in Western Australia, carrying explosives for the mining industry. Fortunately, nobody was injured, but we got a good signal on 3 IMS infrasound stations. So if you want to learn about neighbourhood algorithm source location, please come to my poster. Thank you.
Good morning, I'm Alexander Poplavsky from Capacity Building Training Section, CTBTO. The poster provides an overview of NDC in a box waveform components and emphasize recent achievements and developments, particularly relate to the component 3 major group of components like SizeComp, JetTool, and DTK. The NDC in a box software is developing of NDC in a box is mostly driven by user feedback that's been provided by direct communication or with participants of various workshop training courses, as well as sent to CTBTO support or kind of published anyway on the NDC forum. SNT is a very great platform also to collect feedback of participants, and we warmly appreciate if you visit me and provide your vision, thoughts for the future development of software components. So thank you.
Good morning. My name is Peter. I'm a seismologist, and what we have done is that we have shown that a method on how you can get data from CTBTO through their FDSN web service. And then these data, you can then take them into a software package called Seisen that we use in Denmark and our colleagues in Bolivia and in many other places where there are NDCs using this software package. And if you come to our poster, number 44, you can see how this data are integrated into Seisen. If you're not able to come to this fantastic poster, we have the same on this NDC forum. There you can see videos and you can see documents on how to do it. Thank you.
Yeah, hi, good morning. In this study, we aim to help infrasound analysts to help recognize infrasound signals. So here's the pipeline I'm showing in my presentation, starting with hand labeling about 250,000 infrasound detections, processed with PMCC, then an ensemble model is trained, partly on PMCC-related features as well as spectrograms. This monitoring scheme has been running for 6 months already, and it has shown good results to distinguish between signals of interest, such as quarry blast. It has recognized an ethno-eruption correctly. Also, it's usable to get rid of noise, such as oil refineries and other man-made industrial activities. So if you are interested in the performance, please see my presentation. Thank you.
Hello, my name is Brian Wallace from CTBTO. This poster is really just a self-guided tour about the history of the infrasound software at the IDC. If you want to just read or learn about some of the parameters that go into the automatic pipeline and the analyst review for infrasound, just come have a read. If you have any questions, come find me at my other poster and I can answer them. Thank you.
Good morning, everyone. My name is Ehsan Korbani Chegeni from CTBTO IDC. In this work, we demonstrate the potential of the CTBTO IMS infrasound network for global detection of phenomena such as volcanic activities. We show cases of volcanic activities detected at international data center in different parts of the world. You can see where they are on the slide. We also highlight some of the challenges in detecting such an event during infra analysis at the international data center. So if you are interested, I would be happy to discuss more with you at my poster. Thank you.
Good morning. I am Paulina Bittner, and I am representing analysts from the International Data Center, CTBTO. We started analysis of infrasound data in 2010, so it was like 15 years ago already. Time passes very quickly. And this presentation focuses on the procedures which we use during our analysis, the challenges which we meet, which are much more than a seismic analysis. And also we try to have some suggestions for improvement of automatic products, which is the starting point of our analysis, which will reduce the analyst workload. So if you're interested in what we are doing, please come and see us at our poster. Thank you so much for your attention.
Good morning. My name is Jung-ho Park, working at the CTBTO. I will present a comparative analysis of earthquake locations between Korean NDC KIGAM and IDC REB catalog data. These data focused on the inside the land of Korean networks. This is because the Korean data are used for the reference as like ground truth. And we investigated systematic patterns between locations. The preliminary result shows that the inland of the Korean Peninsula, the IDC REB located a little southwestern reference to the Kigam. And another task applied the impact of the RSTT source SSSC. So we applied the event and compared post and before. And after applying the improved RSTT, then the location accuracy and reliability approved. So if you have interest in this topic, come to my poster. Thank you.
Hello, it's me again. This time, this poster, we looked at phase classification throughout the IDC pipeline, so all SHIs, so seismic, infrasound, and hydroacoustic. And what we wanted to see is how a phase can change, if a phase can change, or if it's deleted. So we look at all seismic phases, all infrasound phases, and just look at trends over time for seismic and hydro from 2001 and from infrasound from 2010, and just see how each land, so in this figure, so on the categorization stage of the pipeline, there's stat pro, which is the initial phase, and then as it goes through the association phase and the review phase, it can change, the phase ID can change, and how does that change over time? And so that's what we're kind of looking at. So if you're interested in seeing how phases change or not change or get deleted from the initial I phase, come check out our poster. Thank you.
Good morning, I'm Jotin Leonel from Dominican Republic, and I will present the poster of the analysis of the Gutenberg Richter in the region of the America. Here we apply the law of the Gutenberg Richter for the America for detect quality data, and also we expect to improve the magnitude that we use in the SSEB. We hope see you soon. Bye. Close my poster. Thank you.
So, hello everyone. My name is Zindim Bouhiaoui from the Center for Research in Astronomy, Astrophysics and Geophysics of Algeria. In this poster, we are presenting a fireball case that occurred on November 24 on 2022. 4 seismic stations recorded the signals from the fragmentation, so we were able to localize the event. 2 freshly installed infrasound stations allows us to estimate the energy of this event. And if you are interested in further information, feel free to visit our stand, our board. Its number is 52. Thank you.
Hi, my name is Raheem, and my poster, we examine a couple of different approaches at event detection on earthquakes that range from a local to teleseismic distance range. Specifically, we looked at 4 benchmark deep learning methods, trained those on our own constructed data set, and examined their ability to generalize to different earthquakes, and found a bit of a generalization gap and sort of examining where these complex models are failing in the generalization gap. And if you're curious about that, come talk to me at my poster. Thank you.
So hi everyone. So my name is Spiro and I'm presenting on behalf of my colleague Svetlana Nikolova, who put this poster together looking at the impact of event definition criteria on the numbers and type of events in the reviewed event bulletin. In the poster there'll be a description of the event definition criteria in a little bit more detail. We'll describe how we've been able to replicate the event definition criteria at our NDC, and having done that, we then can try changing the event criteria to try and improve the quality and numbers of events that make it through to the main product, the reviewed event bulletin of the CTBTO. So thank you.
Good morning, my name is Patrick Cooper from the German NDC, and this talk is about, or this poster is about the noise characterization at the IMS infrasound station and across the whole global network. You see on the pictures that the infrasound stations are deployed in very different environmental conditions, and it's very important to know the noise levels at each station. There have been previous studies, but we do it down to an hourly resolution, and we already applied this data set Julien's presentation he gave yesterday, so you're welcome to have a look at that presentation again. In this poster, I will show a comparison of the variability from interannual to seasonal down to diurnal variation. So if you're interested, please come to the poster screen number 57. Thank you.
So, good morning everyone. I am Sharif Ali from CTBTO IDC, and today I'm talking about the role of scanning process in our event, of our event bulletin. And for us, IDC is producing 2 event bulletins for waveform, reviewed event bulletin and late event bulletin. So the role of scanning of analysts is how we evaluate the automated bulletin to produce the final IDC product. So we are analyzing a automatic process event to produce around 20 more valid events in our final bulletin. And these events, we will discuss them in terms of magnitude, depth, and the contributing station for this event. If you want to see more about our results, please join us in our poster. Thank you.
Good morning. My name is Mario Villagran. I work at the IDC Office of the Director. Given the fact that the waveform components of the IMS has reached about 95% completion, and that the event definition criteria keep, of course, limitation on the number of events, we came with Pierrick and Gerhard to the conclusion that it was a good time to make an attempt of forecasting the amount of events in the REB that will end up being part of the SSEB. We went also into the event screening categorization, and also there are some levels there that have reached some settled numbers. The distribution over the magnitude is also very interesting, and if you want to see more details about all these facts, you are invited to come to the booth number 59. Thank you very much.
Hello, good morning everyone. My name is Armansyah. I come from Indonesia, and I want to show you our hard work in Indonesia to protect our site seismic in Kapi, AS044, from limestone mining activity. And I think this is important for us to know that the area around the site Kapi, there is limestone mining activity, and we have doing collaborations with the local government in that area to stop the activity. And why this topic is important to discuss, because maybe the similar activities can occur in other areas in the world. And then the second is, if this activity is allowed to continue, we have worried it can disrupt our sensor quality data. So if you're interested to discuss it more with us and to find out what's the agreements, I think you can to come to our booth in number 33. Thank you very much.
Good day, everyone. I want to show you in this work is a little analysis of seismic event near to Costa Rica border, Nicaragua. And this work, I use the integration of seismic data and infrasound data with the tools we have in our NDCs in Latin America. And other important thing is someone analysis and one cooperation project we have in Costa Rica in 2019. It's very good solution for our country because we put one portable array to have one point to correlate with the other station near to Costa Rica, maybe Ecuador and other places. It's a little, I want to show you. Thank you.
Hello, my name is Ben Dando from Norsar. I'll be talking about seismicity at the DPRK test site. So we've been running multi-channel cross-correlation detectors back since 2006. So I will show you the performance of these detectors. We have some analysis of how these events correlate to each other, and basically show how they cluster together into 8 individual sets of events. So on the figure here that I'm showing, the blue line is showing what we've detected with the correlation detectors, so almost 200 events compared to the orange line, which is showing the LEB events. So it's showing how well it's performing. And we saw the most activity in 2023 and 2024 with almost 80 individual events. So please come to my e-poster and I will go through it in more detail. Thank you.
Yeah, so we are all using FaceNet and EQT, of course, for face picking on seismological stations. And what we were wondering about is if we can compile a data set based on the IMS data and retrain FaceNet and EQT and check how that performs in comparison to the out-of-the-box FaceNet and EQT models that you can download. And for that, we compiled a data set of all global stations from the IMS, seismological stations, from the last 20 years, and then retrained the 2 face pickers on that. And then we check, of course, how that works on a quantitative scale for comparison with several earthquakes and nuclear explosions as well, with a quantitative analysis where we check the performance of this newly trained IMS data set based face picker on the entirety of 2 years of the RB catalog, and then compare the performance of the face picks with manual picks from the RB catalog. Yeah. See you. Thank you.
Hello again. This job is the automatic determination of the threshold of the CTBTO network. Here we deploy an algorithms for try to find the minimum magnitude consistent that the CTBTO seismological network can detect. Here we have some map and some algorithms that find that the magnitude consistency is 2.4, and also we find so many inconsistent data, mostly in the lower data. We waiting in my poster. Thank you.
Thank you all the speakers and everyone for joining this session. So we have heard a lot of interesting research ideas. So if you would like to discuss with the participants, please visit the e-poster in the next room. Thank you.